So, for example, when you multiply common bases, we're just going to review this quickly on the side. If I take x to the a power and I multiply it by x to the b power, what's my new equation? X to the a plus b. So multiplication is tied with addition. The same is true here with logs. There's reasons we want to expand things. Right now this is condensed into a single log, but you're taking the log of a product. That expands into log base b of m plus log base b of n. So just like multiplying with exponents attaches to addition, multiplying with logs attaches to a separate addition. Does that make sense? Okay. Likewise, division associates with subtraction. So you definitely did these last year, right? You know what? I'm sure you did them. They're not that prevalent on the exam, so it wouldn't surprise me if you didn't review it all that often, just because it doesn't come up on Algebra 2 exams that often. And then this is the biggie. This is the one that's probably the most useful. If you're taking the log of something that's raised to a power, anybody remember what happens? Specifically with this power?
Goes in front.
Goes out in front, yep. So P times log base B of M. With these rules, you'll have to go both directions. You'll have to expand from the single log and spread it out. And sometimes it'll say to condense from the multiple logs. By the way, they always have to have the same base. And they'll condense back in to the single log. So you'll see as we go through these the different scenarios where sometimes you expand, sometimes you condense. Yep. Yes. Not so much the fraction, because that is kind of, if it's written as a fraction, that's kind of a unit in and of itself. But otherwise, if I do log base b of 3x, who's to say that's not log base 3 of base b of 3 times x? So that's why they'll put that product in parentheses. I mean, whatever, yes. So, expanding this. First of all, what's the base on this? 10. So if we expand it, it's log base 10 of 10 plus, because here's your two things being multiplied, a 10 times an x, plus log base 10 of x. So here's a perfect example why expansion can be helpful. Because now that they're expanded in isolation, this one can be evaluated. Log base 10 of 10 is 1. So 1 plus log base 10 of x, or 1 plus log x. Good? Maggie, try to expand that one for me. Yes. And then, Val, what could you simplify about this? To what? Cancel. So that's just 3 minus the natural log of 7. So it looks totally different than the original. Now these, having a calculator is not very helpful. So I don't care. Right. So this would be something that would be on the calculator section because there's not really a way. You're not avoiding knowing anything. By the way, this whole thing, if Val had applied the idea that the exponent comes out in front and natural log of e is just 1, 3 times 1 would still give you 3 if you did that. She didn't really think of it via the exponent rule. She figured it via this rule that we did yesterday. The ln of e just cancels, but that is kind of what's going on there. And C. So this one's going to be tougher because there's an order here that we have to stay with, and the first thing you're going to address is the division. And then within each of those, there's going to be a multiplication. So for example, with this division, this is going to change to log base 6 of the cubed root of x minus log base 6 of 36 y to the 4th. And to answer and kind of piggyback off, was it Faith you asked about the parentheses? You would want to keep parentheses around that and around that. So within this one, there's more multiplication. Yes? And this one, the cubed root, you should change into an exponent so that you can use that property. So log base 6 of x to the 1/3, and you don't have to have parentheses around this one simply because there's not anything more to it. But if you want to just be consistent to keep it clean looking, you can do that. This next part is dangerous because this section, and keep in mind there's a minus out in front, which is why it's dangerous. This section here, when you're taking the product of 36 and y to the 4th, this is going to change into addition. It's going to change into a binomial. And if you're subtracting a binomial, at the very end, you're going to have to remember to distribute. That can be very dangerous. So be careful of minus signs. Log base 6 of 36 plus log base 6 of y to the 4th. So this expanded into a binomial. Given that there was a minus out in front, keep that binomial in parentheses so that we distribute. So we'll look at it term by term now. What can we do to this thing that uses one of our properties? Bring the 1/3 out in front. So that'll be 1/3 log base 6 of x. What can we do to this term? You could. Or treat it as like the what power function. A base of 6 to what power is 36? 2. So that's just 2. So minus 2. And then what can we do with this term? No, you can...
I'll bring the 4 down.
Right. Bring your 4 out in front, and at the same time, can I distribute that minus sign so that my parentheses can be gone? It'll be minus 4 log base 6 of y. So something like that, yes, I would let you have your calculator on. Can you use it in the middle of the problem to sort of cheat a little bit in a way that you shouldn't have to? But yes, I'm fine with that. If you need your calculator in that sense, just because you're so focused on the rules, that's really what I'm focused on, seeing whether or not you know how to do it. I don't want you to get tripped up by putting the wrong number there. I want to see if you know how to do the rules. So that type of question you would have your calculator on. Anything else? No. We're good. So when there's, like if it's just multiplication or just division, fairly straightforward. But if you have to expand something where there's division, and within the division there's multiplication, the organization, the use of parentheses is just much more important. The bottom two examples are about condensing. So they're already separated. Obviously, they both have to have the same base. And addition of 2 logs condenses into what operation? Multiplication. So log base 4 of, if you just want to document your work, you can put down the 2 times 32, which becomes log base 4 of 64. And then what would your answer be? 4 to what power gives you 64? 3. So that answer is just 3. That I might give you your calculator for, but it would be accompanied by the directions that you need to show all work. So you can just plug that in and put an answer of 3 and not have any work showing the condensing. And by the way, that kind of is where condensing is very useful, because in isolation, that's just much harder. 4 to what power is 2? We can do it, but it's harder. What power is it? 1/2. So that would be 1/2 plus 4 to what power is 32? That you really don't know in your head. Because 4 squared is too small, 4 cubed is too big. So it actually ends up being 2.5, which is why 1/2 plus 2.5 is 3. But you wouldn't be able to do this in isolation in your head. So you condense, and now it's doable. Okay, so here's one that's going to be more complex because it's a string of 3 things going on. The first thing I would tell you is take all of your coefficients, bring them up to exponents. On this first one, I might even add to that, rather than writing x to the 1/4 power, I would write it as a radical. 4th root of x, right? Well, I don't like 4th root of x. This one would be log base b of what number? What did you say, Andrew? 25, 5 squared, 25. Minus log base b of y to the 10th. Oh, there's not a lot of room here at all. There are 2 ways you could do this, and I'm gonna show you both at form. Tell me which one you like better. The first would be to take this, turn it into an image, log base b of 1/4 x to 25. And then we still have this minus log base b of y to the 10th. And then this can turn into this, right? Log base b is something, right? Log base b is something. That log base b of the 4th root of x over 25 over y to the 10th. Which is ugly. It cannot be left that way. Because that's not what's correct.
How do you change it?
So we're going to explain it. So if I just focusing on this, each subtraction means division multiplication. So y to the 10th, y 1 over y to the 10th. And so it's going to end up being log base b of 4th root of x over 25 y to the 10th. We level it up. I'm going to show you a different way. I think they both come with their ugly stuff. So you'll have to choose whichever suits better. The other idea would be to almost like unlike what we did there, factor out a negative from the second 2 terms. So log base b of 4th root of x minus, and then parentheses log base b of 25 plus log base b of y to the 10th. That way you can turn this one into multiplication first. If you have 2 subtractions, it's always going to be a fraction within a fraction. That's the pros of that. This one you just have to see that, so that's strategization. And now this one is going to turn into multiplication. And then we have the 1 fraction. What that is that. We do the same thing at the end, so it's going to come down. Use whatever you want. I'm not going to always do it up here as I choose to both things or both space. So copy down whichever one works for you. I know.
You like that one?
No, I like. I love that.
Wouldn't you rather just get something like upgraded? Right?
No, because normally there's 3 advanced classes. Usually there's only 2. That's why I teach you that. And there's 2 advanced here. I actually would rather have them write 3 of the same thing together. So I think that's both ways. I just think that's
Alright. That's the cutest bag in the back.
I don't know. I think that's the backside. What's the backside?
Solving exponential equations.
Oh yeah, we're done.
Yeah, we're done.
Yep. So your homework is coming.
Yo, go.
You have. There's only
Bro, seriously?
since you have 20 minutes to start. Take one test round.
Probably should have fallen out.
You have to do all of them. There's not that many to begin with.
No, how was that?
That's decided.
How you doing? Yeah,
Do you want to start your test?
what are you gonna pick? I gotta do two.
What guys?